welcome back to Visit with Ben. This is a continuation of the video on potentiometer, Wheatstone Bridge and meter bridge. In today's video, we want to do some calculations on the equations we derived in the former video. Please, if I've missed the former video, kindly click in the description box to see the theory of the Wheatstone and the potentiometer, the Wheatstone Bridge, and then the meter bridge. We'll go straight to the point calculations today. Don't forget to subscribe and share this video to those that need it. God bless you. I have some couple of questions I would like us to look at this moment. One is on Wheatstone Bridge. Wheatstone Bridge. It reads, what is the value of R when G shows no deflection in the circuits illustrated? This is the circuit diagram. Right. Calculations. Calculations on potentiometer, Wheatstone Bridge, and meter bridge. Question number 1. This is the diagram of the question. Just sorry, don't mind my diagram. I'm just trying to be fast with the question, but this is how it looks like. Good. Yeah. So here you have 10, 100 ohm. So this is a diagram. Good. So A. So the place of plus, this is negative, the current will flow here, 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 here again. Here, the current will flow here, back here, here again. Good. So the answer, this is 150, here's 150. Here's 150 ohm, and here is 30 ohm. This is 150 ohm. So if you recall from the equation, so you have to find this guy Rx. If you recall, I said something. That the galvanometer will show no deflection when the PD across, we can call this is A, B, C, D. When the PD across A, B is the same as that of what? This and this. Do you understand? Good. So we say that VAB is equal to what? VAD. And AD, this is your current, and here is your I1. Here is your I12. Your I2 is here. Your I2 is also here. So we mean that here will be VAB equals to VAD. Meaning this implies that from V is equal to IR from Ohm's law. Do you remember that video? Please watch. We mean that here you have your I1 RX. I1 RX is equal to what? I2 R2 30 ohm. The same thing here. Here we have VBC will be equal to what? VCD. That implies that your I1, I2 times this. So I1 times 100 ohm is equal to what? I2 times 150 ohm. You can call this equation 1, call this equation 2. So divide equation 1 by equation 2. If you do that, you're going to have I1 RX is equal to I2 times 30 ohm divided by I1 100 ohm. I1 times 100 ohm, please. I1 times 100 ohm divided by what? I2 times 150 ohm. This will cancel this, this will cancel this. So Rx is equal to 100 ohm is equal to 300 ohm divided by 30 ohm or 150 ohm. Of course, this 0 will cancel this 0. This ohm will cancel this ohm. You have Rx all over 100 ohm is equal to 3 here 1, 3 here 5. So you cross multiply, what do you have? You have 5 Rx is equal to what? 100 watts ohm. So you divide both sides by 5. Both sides by 5. Both sides by 5. So if you do that correctly, you have your Rx equals to 100 ohm divided by 5. 100 divided by 5 will give you what? That is 20. Will give you 20. 1 over 5 will give you 20. Yes, correct. So your Rx is just 20 ohm. Let me confirm the answer. That is supposed to be the answer. Yes. There is that for that. The answer is D, 20 ohm. We are correct. 20 ohm. A round of applause for me. Okay, let's move on. The next question I want to calculate right now is a question on, please, you can look at this and then screenshot. It's a question on meter bridge, a meter bridge question. I will quickly draw the circuit diagram so that we calculate quickly. Question number 2 is on meter bridge. Now, the reason why all this is that if you are giving these questions in your external exams, the examiners may ask you questions in BI and BI section of the experiment to do things like this. And if you don't know how to go about it, you're very confused. So this diagram quickly, we have something like this. Good. Something like this. Then something like this. Let me shift this to the center. Good. Mind you, these are copper plates or brass plates. They are conductive materials. Now we have the length of the wire from here to this point. Good. And then we call this is X and this is Y. And then L1. X. So we have a resistor here, a resistor connected here, another resistor connected here. This is the meter bridge, another resistor connected here, and this resistor this is upside down, is 10 ohm. This resistor is 10 ohm, and the jockey, the galvanometer is here, is connected here. Then the protective resistor, the jockey, is placed there. So from this point to this point is your, from this point, let me extend it, from this point to the dot here is your L1. Good. And and this L1 is given to be 40 cm. This is Rx or no. So let me read. In a meter bridge experiment, there is a zero deflection of the galvanometer when L1 is equal to 40 cm, as shown in the diagram on the board. Calculate the value of the resistance R. This R is not given. Now, I told you the meter bridge is a practical application of the Wheatstone Bridge. It is also used to determine the value of the unknown resistance. The Wheatstone Bridge is also used to determine the value of unknown resistance. Now, I told you that if here is 40 cm, the length of this wire, as called meter bridge, as the name implies, is a bridge that has a 100 cm resistance wire stretched across it. So it is 100 cm. So the full length of this guy is what? From this dot to this dot to this dot is what? 100 cm. So if here is 40, it means that 100 cm minus 40 from here to here is 60 cm. So our L2 is 60 cm. So from the equation I gave us, it is simply what? L2 all over what? I would say R all over L2, which is this, 60 cm. R all over L2 is equal to what? 10 ohm all over what? L1. We substitute. So this implies that R all over what? All over 60 cm is equal to what? 10 all over what? 40 cm. So if you do that, this implies that this 0 cancels this 0. We have R all over 60 cm is equal to 1 all over 4 cm. If you cross multiply, you have 60 cm is equal to what? Is equal to 4 cm R. Cm cancels cm. You divide both sides by 4, and then your R is simply 60 by 4. 60 by 4 will give you 60 by 4 will give you 15. So the value for the non-resistance is 15 ohm. That is the value for the non-resistance. And then in the answer we also have 15 ohm, and the option is B. Clap for me. Good. We have solved a question on galvanometer. We have solved a question. A question on Wheatstone Bridge, a question on meter bridge. Can we just solve a question on potentiometer? Yes, let's check if there's something like that. Let's just solve one question on potentiometer. I'm checking if I can find one. If I don't find one, I will just move on. Okay, let me just solve one question more on meter bridge, then we'll be done for today. I'll clean this one and then I will solve this question quickly. This is another question on Wheatstone Bridge. Sorry, another question on meter bridge, not Wheatstone Bridge. Or rather, let's solve one on. Okay. There is a question on Wheatstone Bridge here. Your new school physics, page 407. I read. This is the circuit diagram. You have something like this. I'm having a challenge drawing this. Pardon me, please. Yeah. Then please, pardon me. Just, yeah, something like this. Please pardon me. I'm in a hurry. This. Yeah. So this is your R. This is your 90 ohm. This is your 90 ohm, and this is your 50 ohm, and this is your 20 ohm, and this is your G, and this is your that. So the ask to find R. We are not going to go that deep again, just write. This is the current, this is your plus, negative, current will flow this way and back in here. So this is your I, this is your I1, and this is your I2, this is your I2, this is your I1. So this is your R1, R2, R3, then this is your R1, R4. So right, we said R1 all over what? R1 all over R2 is equal to what? R3 all over what? R4. Do you remember? As simple. This is a shortcut. So we're looking for this guy. So your R1 is what? Your R1 is what? 50 ohm divided by 20 ohm is equal to what? 90 ohm divided by what? R4. This will go, this will go. You have 5 all over 2 is equal to 90 ohm all over R. You cross multiply, what do you have? You have 90 times 2 is equal to 5R. You divide 90 times 2 will give you 180. It's equal to 5R. Divide both sides by 5, both sides by 5. This will go, and your R is equal to what? Give you 36. We have 36 ohm, and we are correct. Yes, here the answer is B. So to this we have come to the end of this class. Bye bye. Don't forget to subscribe and share. God bless you. Bye bye. Thank you.